Okay, this is the geometry circle review with my 8th hour.
Go. Yes!
Alright, anyway. Okay, so let's go with this. So question 1, it's saying, what's an equation of a line of a line of reflection that maps point X onto point Y? So, a reflection, what do we do to reflect? Just fold it, right? So I'm going to use some patty paper so you guys can actually see this here. So I'm going to put X onto Y. Fold the paper. So I got X onto Y right here. And so where I folded the paper at is going to be my line. So it's going to be X equals what? Negative 1. X is negative 1. So all you got to do, put one on the other. What translation could be used to map M onto N? M onto N.
4 units to the left, 4 units up.
4 units left, right? And 4 units up, right? So they're putting this one onto this one. Answer is A. Number 3. All right. What scale factor could be used to make the image of circle X as congruent to circle Y? Now, first, let's find the radius. What's the radius here? 4. What's this radius? 3. Now, it's starting at X and going to Y. So when we do my scale factor, it's always going to be the second one over the first one. The second one over the first one. So what is the second one? So it's going to be, second one is what? Say 3 over the first one, which is? So my answer is 3 over 4, B. Whenever I'm doing my dilation, it's the second one divided by the first one. All right, so this one right here, we did several of these. You had it on your practice, you had it in your notes. We did a couple of these. So now we're going to put maps A onto B. A onto B. So now we start at A and we go to B. So that means I'm going to have a translation of X comma Y. And I'm going, so A onto B, right? So how many, I'm going to the right, so what does that mean? Positive, so I'm going to put X plus 5, right? And then Y, it's going down, isn't it? How much is it going down? Down 3, right? So Y minus 3. Now it has a dilation. Has a dilation. So what's the radius of circle A? 3. What's the radius of circle B? 5, right? So we're going which one onto, so we're going A onto B, 5 over 3. Super easy, right? Did anyone struggle with any of these? Or is it just how to get started? Yeah, what's up?
Well, I don't know how to find type is like 5 over 3.
When I find the scale factor, it's always going to be the second one over the first one. The radius of the second one is 5 because it's A onto B. So that means B is the second one. So it's the radius of 5 over the radius of 3.
So how do you find 5?
Count it from here to here.
Okay.
Yeah, just the radius of the circle, from the center out to the edge. Alright. Alright, let's see this one right here. 5. Find the scale factor of the dilation with the center A maps AB onto AB prime. Explain why that scale factor could be used to map circle A onto circle A prime. So, which one onto which one? Which one's my second one?
A prime.
Yeah, A prime. So what's the radius of A prime?
4.
So it's 4 over 3. Okay, so y scale factor, it's always going to be the second one over the first one. So it's going to be AB prime divided by AB. It's always going to be like that. Alright, you guys are going to complete these statements. So let's first, before I do this, let's find the radius of all these circles. The radius of circle A is 5. Radius of circle B? 1, 2, 3. That one's 3. And for circle C? 4. Alright, so scale factor of dilation that maps circle A onto congruent circle B, 3 over 5. Because it's going from a big one to a small one, right? So it's less than 1. For B, the scale factor of a dilation that maps circle B onto a circle congruent to C. So now if it's going from B onto C, it's going to be 4 over 3. Okay, scale factor of dilation that maps circle C onto congruent circle A. Determine the scale factor of a dilation that maps a circle with the radius R onto a circle congruent to a circle with radius S. S over R. Pretty easy, right? Says, describe 2 different sequences of similarity transformations that map M onto N. Let's only do one. Okay. We could actually do a whole bunch of different ones if I do rotations, reflections, just different things. Okay, so we're going M onto N. So let's start with X comma Y. Okay, M onto N, right? So it's moving to the left, so it's going to be X minus 6. You guys agree? You counting it over? X minus 6, because I start at M and I'm going to the left. Here's 4, 5, 6, right? And it's going up from there, isn't it? That's Y plus 6, because it's going up from there, right? Right? Easy. What about that dilation? This is 3. This is 5. So it's going to be, it's circle M onto N. M onto N. 3 over 5. 3 over 5. It's the second one over the first one. Alright, so you guys, let's see. Complete the proof below. Given circle C with the radius R and circle D with the radius S, prove circle C is similar to circle D. The first transformation circle C with the translation that maps point C onto point. Yep. Because if we're doing the transformation, we're putting C onto D, right? Yes?
Yes.
Good. Let the image of C be circle C prime. The center of circle C prime must lie at where? At point D, right? Because we just moved it over there to point D, didn't we? Now transform circle C prime with a dilation that has a center of D and a scale factor of S over R. Yes, S over R. Because it's the radius of the second one over the radius of the first one.
Yes.
After the dilation, the radius of the image of circle S prime is going to be, this one's tricky. What's the radius going to be now? Nope. It should be just S. So after the dilation, it should be just S, right? Because it's going to be the same as D now. So I'm dilating it, and I'm moving it, I'm changing it. So now, it start off with the R, now it has an S. After the dilation, it's going to be an S. So the center of the image of circle S prime is where's the center of the image? At D. It's at point D, isn't it?
Yes.
Since the translation and dilations are, you can conclude that they are similar. They are congruent. So the translations, and then when we dilate, they're going to be congruent to each other. Therefore, they are going to be similar. All right, let's take a look. This one should be super easy here. What's the measure of angle ACB? ACB is right here. First, what's the arc? Tell me the name of the arc. AB, right? So we're going to do AB. There's my pizza crust. So my pizza crust is AB. So we know that the angle is how much of the arc? Half. The angle is half the arc. So the arc has to be 100. So for the angle to be half the arc, this has to be 100. So what is my central angle now? Central angle is ACB, yes. What's the measurement though? It's also going to be 100. The central angle is the same as the arc. Central angle, same as the arc. Alrighty, on this one right here, which statement below correctly relates angle BDC, BDC, and BAC, BAC? Now, if we're saying that this is going to be a tangent line, what angle goes right here?
That one line.
Right here, what angle goes right here?
That one.
Is this tangent? Say yes.
Yes.
Tangent touches at only one place, so what angle is going to be right there? 90.
Yeah.
What angle's over here?
90.
So 90, 90. So because of that, I'm going to draw this line through here. Now, are these both radius? Is AB a radius? Is AC a radius?
Yes.
You guys agree? Alright, now, let's take a look right here. DA, is that in both of these triangles that I constructed? So I'm going to put a double there. Now let's take a look here. So, because of what we know, these two triangles that I have constructed are going to be congruent to each other because this is going to be a hypotenuse leg of a right triangle. This is also a hypotenuse leg of a right triangle. Because that information, I know that these two triangles are going to be congruent to each other. So I know that this angle is going to be congruent to this angle. This angle is going to be congruent to this angle. Now, I don't know what the values of these are, but since I know that these right here, I'm going to just pretend like I know a value, and I'm going to write it in there so you guys can see this. And then you guys could actually go from there. So if this is, let's call this one 30, then this one is also 30, and that's that angle, and this one, I'm going to say is 60. This one I also say is 60. So, just for the sake of this, I just threw in some numbers just because I know this is going to be congruent like this. Now, right here, these two together are going to add up to what? These two together right here add up to 60, right? So what I'm actually asking here is angle BDC and angle BAC. What do I know about those two there? So this angle right here is 120, right? This angle right here is 60, right? Now, are these two angles complementary? Complementary means it adds up to what? 90. Okay, so it's not 90. Okay, do they add up? Are they supplementary?
Yes.
Yes, they are going to be supplementary because together they have to add up to 180. So I'm going to say yes on this. Now, are they congruent? No, they're not going to be congruent. So no matter what I do, I can't really say that they're going to be congruent. So even if I did say that 45s, would 45s work there? Nope, 45s would not work there for that. Okay, so I'm going to say no on this one, only if it would be 45, 45, 90. And yeah, that one's a no. That one's not going to work. All right, so what about D? Impossible. Say no. Say no.
No.
No, it's not impossible because I already got an answer for B, right? Okay, did I say too many words on that one and everyone zoned out?
Yes.
I'm thinking so, right? So you know, people's faces are being lit up by their cell phone because they're not really paying attention no more, and it's quite funny. Oh no! Pacho's petting zoo. Ah, he's not here. He doesn't show up no more. No. Okay, bye. All right, so right here. Now on this one right here, let's go through and actually figure out what we're looking for. Choose the expression below that are equivalent to measure angle AOB. A to O to B.
Pancho,
What?
you made an error.
I made an error?
I don't know.
A to O to B?
No, not
I was talking about the other one.
no,
The other one, what about it?
let him know.
No, seriously, let me know.
Oh, because, I don't know, because you know how you just put like 60
Yeah?
as an example? I put 30 on the left side.
You put 30 here?
Yeah, 30s, and then 15s on the right one.
Okay, but the problem is, this whole triangle by itself has to add up to 180. This little piece. So triangle BDA has to add up to 180. 30, 60, 90 is 180 by itself. Hey, no worries. You know that's what you're supposed to be doing. You're supposed to be thinking through this. Good job. All right, so let's see right here. 3. So we said, what's going to be the same as this? Same as this angle right here. Angle DOE. So you're saying DOE, right?
Yeah.
That's going to be the same. So if this is 50, this over here is, it's also 50, right? So it's a big thing. So the arc is 50. What about this arc? 50. So let's see. Let's do those. So arc DE, arc AB, angle what? You said DOE? Where we go? Right here. Alright, now let's look at some of these other ones now. Is it 1/2 the angle ACB? So let's see. ACB, is it half the angle? What would this angle right here be? That would be 25, right? So that would be a small number, wouldn't it?
Yes, sir.
Yeah, so I don't want half that. Nope. Would it just be angle ACB? What do we say ACB would be? That would be 25. So that's a no, right? That would be a no. What about 2 times measure ACB? ACB times 2? That would be a yes. What about angle DFE? D to F to E. So what's that going to be? That's also 25.
25.
But 2 times DFE, 2 times DFE would see, there it is. So by plugging in a value right here, it actually helps out a lot. It helps out a lot because I know that if that value's that, it's also going to be there, half values, and 2 times the values. So if we're talking about hypothetical things, give it a number. And then do the equations of multiplying or dividing. Alright, so this one right here. Find measure COD. Alright, COD. So we're going to find this. So first, let's take a look. Now, this is a inscribed angle, right? We know that angle is what? The arc. Half the arc. So what is the arc on this one? My arc, what pizza crust? Label the pizza crust. CD. So I'm going right here. CD is my pizza crust, right? CD is 64 because the angle is half of the arc. Yes? Okay, now look at my central angle. My central angle is COD. So what is the central angle? 64, it's the same as the arc. Alright, let's do this one. What is my pizza crust on this side?
64.
64? Wrong.
84.
84.
Yeah, 84, yeah.
84 because it's the same as the central angle here, right?
Attention to that, that's why.
Okay. So, what is, alright, you could redeem yourself right now. What is the inscribed angle right here?
That's 42, yeah.
42 because the angle is half of the arc, right? So, do we have everything? COD, COD is 64, DBA, D to B to A is 42. Super easy, right? Okay, good. Alright, so let's flip it over. Now, I'm going to give you guys the opportunity. We did. We filled it in on the thing. Yeah. Alright, so I want you guys right now, I'm going to give you guys 1 minute. I want you to do number 5.
Okay.
Using the same steps we did with number 4.
Oh, that was it. The angles and the arc. Oh, that's all we had to do?
I
Ah,
just
but
put it in.
Pancho.
Do you find them all?
Mm-hmm.
Yeah, like the arc and everything?
And everything?
Mm-hmm.
Yeah.
Alright, what'd you get for angle C? Oh, wait, hold on. There it is. Let's go BOC.
B-O-C. And then,
Oh, wait.
pass me that. Hold on.
That's what the question asked for.
Would it be 100? Yeah, it would be 100.
Yeah.
It's something.
Very good. Good job. Who said 100 first?
Yeah, that was me.
Tony.
Tony, that was Tony?
Yeah.
That was Tony.
That was Tony? Good job, Tony. You know what? I'm gonna throw one of those thingies at you.
A pencil?
No.
Throw Adderall at me.
Alright, so let's take a look. So that's 40. So my arc has to be 80. My central angle is 80. And it's supplementary because I want this one right here, right? I want this angle right here, BOC. It's 100 because they're supplementary. My arc out here is going to be how much? This is 60. The angle out here is 120. So the angle right here, what's this one going to be? Okay, so is this 120 out here? Say no.
No.
No, it would be 30.
Yes, very good. That one's 30 degrees. Whoever said 120 just messed up everyone. Alright, so that's 30 now, right? So what is the angle right inside here? 120 because these are going to be supplementary, right? Now it's asking for angle BAO. B to A to O has to be 30 degrees because all three in a triangle add up to 180, right? Alright, let's see if you guys paid attention on that last one. It says MN is tangent to circle O at point M. What is the measure of angle OMN? OMN is 90. Because if it's a tangent, I get a 90-degree angle there. That's super easy, right?
Yes, sir.
Suppose RST is inscribed in a circle with the center O and measure of RST is X. RST is inscribed in the circle with center O. Inscribed means it's actually touching the inside. R, S, T. And it says RST is going to be X. RST is X degrees. If RST is an acute angle, describe the measure of associated central angle. Okay, ROT. Okay, what is the RT going to be? What is the arc RT going to be first? What is it? Very good. So arc RT is equal to 2x, right? And so my central angle ROT is equal to 2x. Same thing.
Yes.
If RST is an obtuse angle, what does obtuse angle mean?
More than 90.
More than 90. Describe the measure of its associated central angle ROT. Now, here's a little cheat right now.
What is it? Please tell me.
So, if you draw it, and we're saying that so obtuse is going to be more than 90. So I'm exaggerating on this one right here. R, S, T. So I'm exaggerating this a little bit to make it describe the measure of its associated central angle with this.
C, senor.
Nope.
What's the other one?
Nope.
Wait, what are you asking?
Wait, how's that?
Pacha?
Okay, look at this. I want you guys to look at this one right here.
Would you ask?
This is 90 degrees. Angle B right here is 90 degrees.
AOB is obtuse.
Okay.
Angle B is 90 degrees because from here to here is the diameter, right? The diameter goes to the center and that's 180, right?
Mm-hmm.
What is half 180?
That's 90.
So therefore that's 90, right?
Yes.
So what if this is more than that?
What it is?
So my central angle, which would be here, is also going to be more than, so my central angle, because if my, let's say this is going to be 120. Is that obtuse? Say yes.
Yes.
And so my arc that goes along with that would be 240, right? So what does that mean about my central angle? It's going to be more than 180, isn't it? So it's going to be, so we normally measure angles less than 180. So a straight line is 180, and then we normally measure it from the smaller. So we don't measure it from the other side. We know it's going to be more than 180, so it's going to be very obtuse. So we know that this one is going to be the same thing, but it's going to be an obtuse angle. So it's going to be more, not obtuse, more than,
More than or equal to 100.
no, just more than 180. More than 180 degrees, so we start looking at it from the other side. We don't read an angle and say, oh, that's a 200 degree angle. The only time we do that is if we're just measuring like for the arc. We always measure from the smaller side. Does that make sense or no?
Yes.
So just try and draw your picture for each one of these. It helps out. So, all right, consider this right here. Measure of arc is equal to the measure of corresponding central angle. Write an equation for measure of arc AB in terms of, so AB is in terms of A in BC. So we know that, I'm going to finish off with this one here. It's going to be the last problem. All right, so we know that arc right here, so we're figuring out arc, measure of arc AB, which is here. Okay, so now in terms of this, right, would be equal to, because this goes all the way through, right?
Yes.
So yes, they're going to add up to 180, right? Because it's going to be supplementary. So what would I say for this? I would say that it would be equal to what?
BC minus 180.
Close. 180 minus BC. Very good. So 180 minus measure arc BC, because we know,
You would get a negative.
because otherwise you would get a negative, right?
Yeah.
So that's writing it in the other terms. It says use triangle ABC to write an equation for angle ACB. ABC to write measure ACB. A to C to B. So I'm trying to figure out this one right here. In terms of angle BAC. BAC. So from the whole triangle here, oh crap, I'm off the page. All right.
Yes.
So this one, in terms of this one. So what did we say the angle B is right here? 90, because the angle is half the arc. My arc is the diameter, so that's 180, right?
Yes.
So that's 90. So I know that the measure of angle ACB is equal to, these two angles together have to add up to what? Nope. 90. These are complementary right here. These are 90. Because all three together have to add up to 180. So take 180, subtract my right angle, and that means I only have 90 left. So it's going to be 90 minus measure angle BAC. My last one, it says that BAC is 27. Find ACB. So we said BAC is 27.
54.
I'm going to put 27 there. This one right here is going to be what? What is it?
The arc?
This one right here. No. I want this one right here.
I'm fine with
It says
that.
ACB.
Oh, 63.
63. So, arc AB is? Arc AB?
It would be 126.
126. 126 because it's twice the angle, right?
Yes.
And arc BC would be
54.
54. All right. Don't forget, like, share, and subscribe. Hit that notification button. So if we're testing on Thursday, what is also due Thursday?
No.
Notebook.